Now I'm going to pretend like I know what I was doing. Theoretical calculations regarding the interaction of forces and members are derived from the centroid location. I think this is fun. We're actually going to, Monday, we're going to get like an odd shape, like a piece of cardboard or paper. We're going to cut it into like a weird shape. We're going to find the middle of all those shapes and the areas of all those shapes, and then we're going to, at the very end, put a dot at the centroid, and then you're going to hold it up like this on your finger, and it will. Did I just hear a weird noise back there?
No.
Okay. And then it will like balance on exactly where you put your finger. One can determine the centroid location by utilizing the cross-section view of a three-dimensional object. What is a cross-sectional view of this? Like if you took a knife or, I don't know, a circular saw that cuts metal, like that, what would the cross view look like if you broke it open and you looked at it just face on? You're gonna like cut it in half like that, and then you're gonna splice it apart, and you're gonna look at the face of it. What's it look like? Looks like an eye. Yep. And it'll look like this. So cross-sectional views. It's an eye view, so it's gonna look like an eye no matter where you cut it. Okay, let's talk about symmetrical objects. Symmetrical objects don't always happen, so don't get too excited. So with a symmetric, we can have this isosceles triangle. An isosceles or equilateral triangle. The centroid is located on the line of symmetry. Okay, if it is a square, if it has multiple lines of symmetry, this one has tons of lines of symmetry, right? Isn't that a line of symmetry too? And that's a line of symmetry. Oops, if I could draw better. Right? And the circle has infinite amounts of lines of symmetry. A line of symmetry is where you can fold it. I just taught that on Pilates, right? Okay? So it's where the lines of symmetry cross. The centroid of a square, just a square, not a rectangle, or a square, is located half, well actually it's the same thing for a rectangle. Half the distance from its height and half the distance of its base. So we would write that x bar is like the x location of the centroid. So we would write 1/2 of the base, or you can write base over 2. I don't care, whichever one you're more comfortable with. Same thing for the y. It's 1/2 of the base, or, I'm sorry, height. Or height over 2. So x bar and y bar, they mean like the middle spot. The centroid of a right triangle is not 1/2, it's 1/3. So if you have a right triangle like this, okay, however high it is, let's call this the h, let's call this the base. Ooh, it's so weird. It's 1/3 of each of those. Okay? So x is 1/3 of the base, and y is 1/3 of the height. You could also just do base divided by 3 and height divided by 3. But I want you guys to see this. Like, let's pretend I did half instead. Let's pretend I did half and half. I want you to look at that blue dot. If that was like a piece of cardboard or maybe a piece of lumber cut in the shape of a triangle, if you put your finger on that dot and you held it in the air like this, would it fall or would it stay? It would fall, right? It would fall towards this side of the triangle. It would go right on the floor. Because you would say, Miss Langella, it's not the middle of the triangle. It's not the centroid of the triangle. So it's at 1/3 and 1/3. Don't you think if you put that would be a much better spot to put, like, to balance it? So that's the centroid. You're looking for its balance. I always think about it, the balancing point. All right. Now, we are probably going to encounter semicircles a lot. The semicircle, the x bar, it depends on how the semicircle looks. I would suggest, if I were you guys getting out your formula sheets, making sure that you know where to find these, because they are on your formula sheet somewhere. Someone find them and tell us what page you're on. Is this still okay back there?
Uh-huh.
Fine. You're fine. Fine. Oh, I have a formula sheet too. Because my desk is a mess. Here, I think it's on. Who found it? I got string. Squirrel. I almost hit a squirrel today. There it is. I got it on page 5. Yeah. Let's talk about this semicircle. Now, I will tell you this semicircle I think is a little misleading because not all semicircles are going to be horizontal semicircles. Okie dokie. So, let's talk about the 2 different situations. If, and I don't have this in my notes, that's okay. I'm smart enough to do this. Don't worry. Okay, guys, when you have I call this a horizontal semicircle because like the diameter is horizontal. If you have a horizontal semicircle, the midpoint of the x-axis, if you picture this like an x-axis, is just half the diameter. Does that make sense? Or better known as the radius. Does that make sense? So the middle of the circle is half. Okay, now y bar, you don't want to go up to the radius on there because you're not going to write equal r because that would be way up here. We need it to be right here. Okay, look at where I'm pointing. Where my finger is kind of like shading. Do you guys think this has more area to it or this where my finger is shading? Just the line my finger is shading. Do you guys think this one has more area or this one? Top or bottom? The bottom has more area. Therefore, your centroid is going to have to kind of like come towards the bottom a little more to help balance that extra weight. So here is the fancy formula. The y bar is 4 times your radius divided by 3 times pi. I would suggest putting 3 times pi in parentheses. If you look in your formula sheet, you will see that that is also how they label it, okay? In equation 10.6. But let's say that some jerk teacher flipped it upside down or sideways like this, a vertical semicircle. Now, the y bar, the half is the radius, and the x bar is 4r over 3 pi. So when you get a picture, please make sure that you appropriately label it. Okay? Does that make sense? All right. Because that's not on your formula sheet, so you're going to have to know if it's a vertical circle to switch what you see. This looks extremely, maybe extremely intimidating. Don't let it be. My 10th graders, do you guys don't know what this fancy E is called? You ever seen it? It's okay. What about my seniors? What's this called? Summation. Very good. We're gonna add all the x bars times all the areas and divide about the total area. That's how you're gonna find it. And the long story short is you're gonna have complex shapes. Complex shapes are gonna maybe have a circle and a triangle and a square together. It's gonna look like this. It's gonna be like a square here, but then go down to a triangle or a circle. It's going to be a weird shape. So what you're going to do is you're going to find the x bar on all of them. You're going to find the y bar on all of them. You're going to multiply by each of their individual areas, and then we'll find the total. It's not that. I promise it's not as overwhelming. I give you a really, really pretty chart. You're going to love the chart. So don't let that kind of mess you up. So I guess that means you need to make sure you know how to solve for the different area of shapes. Do you guys remember what's the area for a square or a rectangle? Good. And you might say, Miss Langeli, I thought a square was S times S. So it's just, yeah, I know. It's the same thing as a length times width. Triangle. Who remembers area of a triangle? Boom. Do you guys know why it's a half times the base times the height?
Because it's half a square.
It's half. Yeah, it's half a rectangle. Base times height is rectangle, and half of a rectangle is a triangle. Amazing. Circle. What's your area of your circle? Nope, that's the circumference.
Pi r squared.
Pi r squared. Good job, guys. Very good. All right. There are 2 ways to do this. Are you excited? Woo-hoo, good. Me too. I'm always excited. excited. Oh my goodness. I can't say students' names when I'm being recorded, but this is from the first year I taught it. He did a better job than I did. So I said, can I have your paper? Oh, I wish I could get a hold of him and tell him. Okay, so this little shape-a-rooney, I think I'm okay. If you guys just really, really, really check me, I think I'll be fine, okay? This little shape is an odd shape. It looks like Miss Langeli made it up. That's because I did. I see what kind of shapes do you guys see with this? It's not a square, it's not a triangle, it's not a circle, it's made up of different shapes put together. What do you see? Yes, I see a triangle here. So let's call that shape 1. That's the first one she found. Triangle. What other shape? Actually, I'm going to make the triangle the way that we see it up there so there's no confusion for those of us who are not here today. What's another shape you guys see? The leftover shapes. Where at? I see 2, so I didn't know which ones you want to pick. Do you see a tall rectangle like this or a horizontal rectangle? Okay, me too. That's fine. You can see the horizontal one. So we'll call that shape 2, tall rectangle. And shape 3, guys, perfect little square. I'm going to do this. I'm going to write that the square is 3 by 3. You guys see how I say 3 by 3? Like 3 grid lines. The rectangle is 6 units tall, 3 units wide, and the triangle is, oh, I did that on purpose for you. It's a 3 by 3 triangle. I did that on purpose so that your 1/3 equations work out nice. I'm a nice person. Good. All right, cool. Shape 1. Let's dig into it. Something you have to do when you're teaching, when you're learning how, you have to record yourself teaching a lesson to a group of students, and then you have to watch it and analyze it. I refuse to watch myself teaching because it's the worst thing ever. Okay, shape 1. Triangle. Okay, do you guys see this really pretty chart? I made that. That may or may not be given to you in the project lead really fine. So I had to kind of remember it on here. Or maybe I'll just have some sitting on the side. I didn't say that up front. All right. Also, you might only have 2 shapes. My default, I give you guys 3 shapes. You might not need the 3rd shape. Everybody okay? You tired? Okay. You're excited, right? All right. X bar. You're not going to like what I'm going to do, but I don't care. All right? That's okay, though, right? Okay. Do you guys agree that since it was a 3 by 3, you always do 1/3 of the base? So that's 1/3 of 3, which is 1. Don't circle that 1. We'll deal with that in a second. There's more. Y. Not WHY. Let's do Y bar. 1/3 of the height, which is 1/3 of 3, which is 1. Don't circle that because it's not done yet. We'll get to it in a second. Move to the square. Is it still recording back there?
Yeah, you have like 2 minutes.
Move to the rectangle. Is it counting down?
No.
If I use the one program, I can record as long as I want. If I use another program, it's like 15 minutes. Let me know if it shuts off. Okay? If it shuts off, just hit record again. All right. Shape 2, X bar. How do we do this? Is this 1/2 or 1/3? 1/2? Nice. 1/2 of what's the X value? How wide is it? Who? Good. So that's 1.5. Don't do anything with that. We might do more in a second. And Y, is it 1/2 or 1/3? Y bar. Remember, we're just finding the middle of it. 1/2. And then how tall is it? So that makes 3. We might have to manipulate that. Just hold on to it for a second. All right. Shape 3 is a square. Is the shape I was trying to spit out of my mouth. So for a square, do we use 1/2 or do we use 1/3? Yep. So 1/2 times 3 is 1.5. And again, 1/2 times 3 is 1.5 for the y's. Now, if you remember, I was like, don't circle those answers because we're going to have to manipulate them. Please remember these shapes exist within an XY axis, in a plane. Let me say that. These shapes exist within an XY plane. So if I say